Okay, I see we're online here. Was just going to do a little welcome to everyone and thank you for joining this mass meeting of April 23rd, 2021. This is our 10th Zoom meeting. Everybody watching on Facebook, YouTube, and our website, MASSCosmos.org, welcome. Our topics tonight are going to range from current events and scientific discovery to, things happening in the space program. I've got about 7 slides of topics, starting with introductory topics. Then we'll move on to Mars. Ingenuity, doing that first powered flight will be kind of our lead story tonight. And then we'll move on to some NASA topics, a physics topic, astronomy topics, a few general topics that I couldn't really qualify as anything. And then we'll wind up with Spacex, which we never miss an opportunity to talk about SpaceX. So our meetings can be several hours long, anticipating maybe going to 9:30 tonight, so that'll be about 2 hours. But if you're interested in a specific topic, on the YouTube video, Keith will be putting out topic links there so you can jump to any one of the sections of our meeting if you so desire. Sometimes our meetings are kind of like eating an elephant. You have to do it one topic at a time or one bite at a time, that kind of thing. So, I guess thanks everyone for joining, and we'll get started. Before I share my screen, I wanted to show one thing here. The library, I hope this isn't backwards. Let me see if, is it backwards? Can you guys see it without the reflection? Oh, it is backwards.
Yeah.
No, it's okay. I can read it.
Yeah, you can see it.
But it's the book Extraterrestrial by the Harvard astronomer Avi Loeb. And I've patiently waited about 2 months, putting the book on hold and waiting for everybody in every other library system in the western suburbs here to read it.
Oh, you're the guy. Oh, I'm waiting.
Yeah. Now it's going to be my chance. But
okay.
I've seen Avi on at least 5 YouTube podcasts talking about his book. It's very controversial. His theory is that the Oumuamua, I'm getting better at pronunciating that, was a extraterrestrial object and not just a comet or a burnt out or asteroid. So I guess the book was going to kind of present his case for that, but it's definitely not what the consensus of scientists thinks, but he's out there saying that Oumuamua was our first sign of intelligent life beyond the Earth. So it'll be an interesting read. I'll give you guys a little report when I get done with it.
Okay, thank you.
Cool.
I have a question on that.
Yeah, with that, I'm going to share my screen and we'll get started here. So, for the background here, I've got Ingenuity on the surface of Mars. Interesting shot there.
Nice and clear.
Yeah, good. Is it technically working for everybody here?
Yeah, looks great.
Okay.
Oh, yeah.
So introductory topics, we covered the extraterrestrial book. I'm proudly reporting that we've got about 100 views of our first YouTube meeting. Kudos to Keith for that great production intro. I think maybe some of those views are just to check out that intro.
Yeah, everybody's made comments where I'm at.
Thanks. It was fun making it.
Keith, have you got any feedback? Because you're probably the best knowledge of our Facebook friends. Have they kind of taken part in it?
Actually, I've had several emails from moms talking about getting their kids more into space and wanting advice. I actually created a standard template that shows all great links going to, Kids Space and a bunch of other things, and also give them ideas of, how to share the adventure with them to explore, astronomy and space science and everything, getting them all excited. So we actually got a few emails for that. We have over 100 views on YouTube, which is great. And I'm going to parse this to a larger group after we posted this one. And we're going to have a larger audience in the near future.
Very nice.
Very good. Yeah. Well, we'll see how it goes here. Next topic. Anybody partake in Yuri's Night Out?
When I was doing my internship at Adler Planetarium, we always celebrated it. It was very cool when we did it. The public were invited, of course, and it was scopes out on the tarmac there, and it was just wonderful having the youth there and moms and dads. And fortunately, or unfortunately, either way you look at it, it's interesting when you get somebody behind a telescope and an eyepiece and they're actually looking at Saturn. It's like, oh, that's a slide. That's not real. Yeah. So how many people have not even seen what Saturn or Jupiter look like through the telescope, especially Saturn? It's just absolutely astounding.
It is. It's very pretty, very beautiful.
Yes, so Yuri's Night was the night of April 12th, and it's held on the anniversary of Yuri Gagarin's first manned flight, which this year we celebrated the 60th anniversary of that.
Mm-hmm.
And ironically, it's also the 40th anniversary of the first space shuttle flight. So
right.
It's odd that those two things happened on the same date of the year there.
Yeah. STS-1, Columbia.
I know Beth was involved in a kind of a big thing, and I tried to connect on Yuri's Night Out, but I think the servers got overwhelmed, and I got all kinds of 404 errors and things like that, so I didn't really get a chance to participate, but it sounded like they had a real who's who of guest speakers and things like that. Now, I'm going to continue my little bit of my puzzle thing here. If you guys remember last meeting, I kind of talked about my moon puzzle. So I've moved on from my moon puzzle to my Pluto puzzle.
And you made substantial progress there.
I knew you complimented me on my progress on the moon puzzle. Dean, this is all, I'm kind of doing this with smoke and mirrors because I thought at 550 pieces, this should be a couple orders of magnitude easier than the 1,000-piece moon puzzle. But there's tons of pieces that are exactly the same size. And, you know, I'm pretty confident on the circle of the planet, I'm okay, but somewhere I've put in black pieces here that don't quite fit. So none of these pieces fit anywhere on the periphery.
Wow.
And you guys are, you know, I'm swearing at this thing. And
the next question is, how's your back compared to doing the moon one?
Well, you know, my puzzle back is doing better because I just kind of sit in the chair and swear. And, you know, and there are a few pieces here you can't tell, but I just took my 300 pounds and pressed as hard as I could, even though it wasn't quite fitting. It looks like it. I have never had a puzzle where I had the border all identified and I can't put it together. You know, it looks like it's together here, but there's like a part over here that's about 1/8 of an inch off. And there's a part over here that's 1/8 inch high. And I won't moan anymore, but my strategy after today is to probably remove all the black pieces and start over. And if that don't work,
you'll swear
that's
again.
It's going to be really hard with no pattern to follow.
yeah. There's.
Well, you got a good view of Sputnik Planum, though, at least.
Yeah, you know, I love the heart on the.
Yeah, it's beautiful.
On Pluto there. So we'll see. This will never. I don't think I'm ever going to attempt it again. So if I do get these black pieces in there, I'm going to Hobby Lobby and get that glue that you can put on the puzzle and turn it into a wall hanging. But
very cool. Very
so
cool.
How do you know they're not machine cut wrong? You know, maybe possibility.
Yeah, wow.
That's a good question.
I'd like to blame the manufacturer, but Astronomy magazine didn't even actually say who made it. So, I don't know who to blame.
All right, they're no help. All right.
Well, that's new on Puzzle Talk. Jeez,
yeah, so
all look the same.
Yeah, we'll have to see here. So my next topic, I'm gonna kind of be a blatant advertisement for our mass prize here. You know, monthly, I was saying that I'd put out a little progress thing, and we actually got some people in space. So under, let's see, mass on commercial crew, you can always every month go there and look at the guesses of the group. And we've got some progress now. We've got a red bar coming up here and we're at 7. So we had 3 fly on Soyuz and 4 fly on Dragon this morning. So we're at 7. Here's the guesses of everybody. Silvio, you were the most pessimistic, and Beth was our most optimistic. And then well, you know, you can track it every month. And the other thing here I'm going to do is there's a blog, Jim's blog here, where on a monthly basis, I'm going to give a little update on
very good.
manned space. Kind of talk about the 5 spacecraft that fly from the United States: Crew Dragon, Starliner, Orion, Spaceship from Virgin Galactic, and New Shepard from Blue Origin.
Cool. And
try to keep like a little monthly, what's the latest progress on there and what my guess is from, you know, like a subsetting standpoint, and then come up with a new guess each month. This current month, even though we've had 7 people fly, I'm down 3 from last month's estimate because I do not think the Starliner is going to carry people this year. Starliner now, the redo of the unmanned test is actually slipped to August and September because they can't find a port available on the ISS because of all the traffic coming and going. And because they're relying on a Atlas V rocket, and ULA is launching a lot of Atlas Vs for the Department of Defense, I think they're having a hard time finding a launch date. So
at least it's not technical.
Yeah, right. So I have a feeling the manned Starliner thing won't happen until February of 2022. So we'll see. But anybody interested, if you look for an update on this, usually I'll put it out around the 1st of the month. I did it yesterday just to kind of show it to you guys today and let you see. So
I can put a direct link on Facebook to that too, Jim.
Okay. And, you know, don't think I'm not being able to shift my guess. I'm just modifying my guess as the months go by. I'm stuck like everybody else, I think, with my original guess of, I think, 27. So we'll see how we do. So that's my my thing there. Check out the blog and check out the progress on our website. Another thing that happened, and I don't know, Keith, if you got a chance to see it, was the Gerard O'Neill documentary.
I did not. I wanted to, and then I got directed for something. I have to go back to that.
But they've come out with a new documentary on this guy. He was a real visionary early in the space program, and kind of had a movement of converts talking about humans in space and building cities in space. I think that kind of morphed into the L5 society, which then got assimilated into the National Space Society. And, you know, it's pretty epic guy there. I watched it. I learned quite a bit about him. I wasn't a real expert on him. And it's the documentary is called The High Frontier. It's out on a lot of different platforms. I don't know if it's free. I know the premiere was free, so that was the one advantage of watching it that first night. But just to kind of let you guys be aware of that. So it's called The High Frontier. Speaking of National Space Society, I also participated in, Jim Plaxco had another meeting of his Chicago, let's see, what was the proper term for that? Chicago Space Studies Society, something like that. And he had a guy from the group give a talk about the Sloan Digital Sky Survey. And I never knew this guy, Larry Botozik, actually worked on the telescope down at Apache Point. He designed the latches that held the camera to the telescope while it was doing its business. And that Sloan Digital Sky Survey was a real epic study of kind of studying all the galaxies in the cosmos in a 3D manner. They would take a spectrograph of every galaxy, so they'd be able to compute a distance as well as an XY location. And we're able to plot out that galaxies formed in sheets and there were big bubble voids and things like that. So it was a pretty interesting talk. I know the survey has been going on even now. I guess they're on to this digital survey number 5. So interesting that we had a local guy here that had worked on that. So that pretty much completes my intro topics. Anybody have any other general topics?
No, but I do remember Apache Point. When I was doing research at LARC at Northwestern, LARC is short for Lindheimer Astronomical Research Center. There was some correlation between LARC and Apache Point. So, and I'm not exactly sure, but when they dismantled LARC, unfortunately, I think the mirror went to Apache Point, the telescope. So I'd have to do a little bit more research on that. But we were kind of doing quasars and Markarian galaxies in tandem with Apache Point. So it was a good compilation between both our facilities.
Okay. You know, before we left this, I was going to ask Dean, I had heard that, you know, Bezos of Amazon is going to be in competition with SpaceX and their Sky or Starlink,
Starlink, yeah.
from space.
Yeah.
And Bezos actually purchased 9 Atlas V rockets. I thought Atlas V was going out the door and just was surprised.
I think it was supposed to be replaced by the Vulcan.
Right.
But if maybe he bought the last remaining on the shelf, you know, before they switch over to the Vulcan. But I know they've made substantial progress on the Vulcan booster.
Yeah, and that's even supposed to fly this year, and it's supposed to fly with Blue Origin, which is Bezos's company's engine. So that's why it just seems so weird that he would purchase 9 Atlas V's. But
well, we'll have to see how many he puts up at one time. You know, if he's going to do that, and what orbits. Elon Musk puts his Starlink satellites in very, very low Earth orbit in abundancy. You know, he launches 60 at a time. So if you lose one, there's always one to make up. I think Bezos is trying to get out closer to geosync and satellites that are a little bit more expensive than what Elon Musk has, and they can last for years for the complete internet coverage. If he's able to purchase 9 atlases, he certainly can produce some very nice satellites at geosync orbit.
Yeah, an Atlas V, as I recall, wasn't that cheap.
No.
And I've heard that Bezos plans to spend 10 billion on his satellite constellation is called Kuiper.
Right.
And the one thing that's kind of holding over his head is, you know, he hasn't launched any satellites yet, and the FCC gave him a deadline of 2025. So if he doesn't get his 3,200 plus satellites up by 2025, he's going to be in trouble.
Yeah, he doesn't have to worry about his lander now. So
Wow.
yes, already picked the moon lander.
Okay, well,
so
I was surprised to see that.
yeah, I was very shocked also. I'm sure that's a topic that Jim's going to talk about.
Oh yeah, definitely.
You know, if it wasn't for Ingenuity's first flight, that probably would have been our lead story today. But we'll move on to Mars topics right now. And Ingenuity first powered flight on another thing here. Let's see. I think I've got a short video here. You know, here's a picture of it taking its picture of a shadow on the ground as it flies. And then here it is getting ready to spin up.
Just amazing.
Yeah.
While it's in flight, is it taking video? Is it taking measurements in the atmosphere? What's it doing?
Oh wow, look at that.
No, it's just taking a picture of its shadow on the bottom. This is just a demonstration flight. It doesn't really do any science except for just pictures. It has one color camera and one black and white camera.
Gotcha. Thank you.
I haven't seen this yet.
Right. So what it did is it went up about 10 feet in the air. It did a 90-degree rotation and hovered for another 20 seconds and then landed. So it was a 39-second flight. And you might say, oh, that ain't a big deal. But if you...
it is a big deal.
Oh, yeah, with pressure in the atmosphere being different than Earth, yeah.
Right. If you go back 117 years to the Wright brothers flight, that only lasted 12 seconds. And, you know, those guys got immortalized on postage stamps and, everything under the sun. So...
quite an amazing feat.
You know, and I didn't even realize it's already flown a second time.
Right.
And then this coming Sunday is going to be its third flight. And, you know, like you told Silvio, it didn't try to take any color pictures on that first flight, but I think the second flight, I think it did try taking some pictures. And again, part of its contribution is going to be maybe to take some close-up pictures of the path that the rover will take.
Okay.
I still remember the rover having 2 possible paths, and maybe Ingenuity would help them pick which of the 2 it's going to take.
That would be great.
So every flight they're pushing the envelope a little bit more. Here on the left is Mi Biang. She's the head of the group that's handling the helicopter, and then the chief pilot is a guy named Hovard Grip, Grip, and he's Ingenuity's chief pilot. And the cool thing is they actually got a designation of JZRO for the location of where they're in, you know, short for Jezero.
Right.
And they've named that little airfield that they designated now as Wright Brothers Airfield.
Yeah, that's so cool.
So
appropriate.
Yes, and then the International Civil Aviation Organization gave the helicopter the designation IGY, and a call sign of Ingenuity. So so Ingenuity's pilot could make log entries of the flights, and just like Harry does on his plane, and where he takes it to, they're really doing it.
Yeah.
And I love the team's thing up on the wall here, Dare Mighty Things.
Yeah, very cool.
You know,
so I just want to explain to Silvio what we were doing with this. The first flight was only 10 feet high, and it went up and down and hovered and did a little turn, because you can make sure we can rotate. The second flight, which was yesterday, Thursday, it went up 16 feet, so 6 feet more than the first flight, and it went laterally 7 feet. So it actually went up and then went over 7 feet, rotated, and then went back to the landing zone and came back down again. So as Jim mentioned, each time we're pushing the envelope. Remember, this is just a demonstration of the technology. So we may as well push it as far as we can.
Oh, sure.
And I do have a little video of that second flight, but I was surprised that it was already in the air. So I don't know if there was a little timing problem of the video, but see, they already have it in the air. I didn't notice the 7 feet lateral, but they identified this as the second flight because it's doing 2 rotations.
Mm-hmm.
But maybe it was 2 in forward and back from the rover, so you couldn't really tell that it was doing that horizontal translation. But yeah, like Dean said, the third flight on Sunday, they're actually going to travel maybe 50 meters or 164 feet out and come back. So total distance of 100 meters traveled, or 330 feet. And it might be in the air for about 80 seconds. So we'll see how it does. You know, they have to, I think their biggest concern is maybe winds can, you know, affect the flight. So sometimes they have to really watch out for what the weather's doing.
You know, what about the Martian dust? Does that hurt this?
You know, I didn't see a lot of dust in the normal videos, but I've seen an enhanced video that does show it kicking up some dust.
Yeah, it's less than what they anticipated.
Good. You know, it's just an exciting time to hear about this, and a lot of questions come to my mind.
And the other exciting thing that happened was MASSCosmos.
That was incredible.
Yeah, the instrument to actually pull carbon dioxide out of the atmosphere and turned it into oxygen, actually made 6 grams of oxygen in an hour. And,
awesome. That's amazing.
Yeah, it's all built in this little thing here. It's got a tube to bring the air in and filter it. It pressurizes the air a little bit. And then it, I think, has a solid kind of catalyst where it'll pass the carbon dioxide over there, and an oxygen atom gets kicked off that it pulls off. And
yeah, they have to heat it at 1200 degrees.
Yeah, so it's yeah, like ceramic kind of technology. And you know, although it's small, you know, it is limited by power because it takes a lot of electricity to do this process. I think in the long run, that 6 grams of oxygen is only enough for a human for maybe 10 minutes of breathing. And you know, one thing, it doesn't sound like it's too eco-friendly because it gives off carbon monoxide when it takes that oxygen off there. So I don't think we want to try that process here on Earth as a way to reduce our carbon footprint. We don't want to replace carbon dioxide with carbon monoxide. That would be a good thing. And
Dean, this is the one that I think Zuperman keeps talking about, right? Robert Subaru, Mars.
Oh, yeah, the ex-NASA scientist who wanted to keep Mars alive, obviously, and going to Mars and settlements on Mars and all of this. But I'm sure the future part of MOXIE will be producing ones that will eliminate the carbon monoxide, you know, after, because you can always take that type of information that it produces and try and dwindle it down by either remanufacturing the carbon monoxide before it's released into the Martian atmosphere. Again, MOXIE is a test of if we can do this, you know, and obviously we have, and now we know what the situation is with, after producing oxygen, what the offsheet is, which is carbon monoxide. What do we do about trying to eliminate that?
And this is that of the first experiment of what they call in situ resource utilization. You can reduce the cost and all kinds of issues with your flight to Mars if you can produce the materials you need at the site rather than carrying it with you. So, you know, what they were estimating is 4 astronauts landing on the surface would need 7 metric tons or 15,000 pounds of rocket fuel, which could be like methane, and they'd need 25 metric tons or 55,000 pounds of oxygen to get back up off the surface of Mars. So, you know, now we've made 6 grams, but eventually we want to make 55,000 pounds.
Wow.
Yeah, these will be much larger facilities. You'd probably be on Mars for about 2 Martian years, which is over 1,200 days to produce anything like that. So
right. And it's funny, you can kind of see if you need 55,000 pounds of oxygen for mixing with your rocket fuel, but breathing for astronauts for a year would only be 1 metric ton or 1/25th of what you need for your rocket engine. So it's a lot easier to get the oxygen for the astronauts to breathe than it would be to get the oxygen for the rocket to work blasting off of Mars.
But we certainly don't want to replace Mars's carbon dioxide with carbon monoxide.
No.
So there's plenty of CO2 in the atmosphere, but you don't want the carbon monoxide either. So there'll be steps to try and eliminate that on future projects. But we know it works. So.
Yes. And, you know, I just wanted to talk a little bit about the weather on Mars. We've got an instrument called MEDA, MEDA, for Mars Environmental Dynamic Analyzer. That's on an hour-by-hour basis. It's developed by Spain, weighs about 12 pounds, and can record dust levels and 6 atmospheric conditions of wind speed and direction, pressure, relative humidity, air temperature, ground temperature, and radiation, both from the sun and from space in general. And it records every hour. And it was kind of interesting. Here is like what it was saying right when maybe within the hour after it had landed, or maybe this is actually Sol 61, which would be 61 Mar days after landing. The high was a -8 degrees Fahrenheit.
Yeah, we could deal with that.
Yeah. Well, the low of -117.
Yeah.
And I guess -130 is not that uncommon. So that's why when the Ingenuity had trouble with its software and they were going to let it kind of sit on the surface for another week while they uploaded new software, I was just worrying about these 130 degree below nights and what that would do to it. But I guess the heaters managed to fight off the cold. And Dean, you said you wanted to talk a little bit about that software update?
It's the software update and just testing Ingenuity in basic principle is that JPL has a vacuum chamber, and it's got fans in there also to simulate wind on Mars. But the only thing we cannot simulate on the vacuum chamber is the gravity. And that actually worked to our advantage because we have more gravity than Mars does, about 2/3 more than Mars. Mars is about a third or 2/3 of the gravity that we exhibit, but more gravity, and we were able to pump it down to equal the amount of pressure that was on Mars and test Ingenuity, the real helicopter itself, not the sister ship that we use for testing. But and it flew in the vacuum chamber. In fact, it flew so well that we knew basically in our mind that it would fly on Mars because there is less gravity on Mars, less pulling of the helicopter down. So it worked really well. But they were debating whether to change the software completely, which would take several days, or I guess put what you would say a patch in there. And nowadays, and it started with Curiosity, we didn't have that option when we were doing the software for Spirit and Opportunity. And that's where we got the idea to write patches of programs and stitch them together instead of just one long program. So what they did is they found out the difference between regular mode and flight mode of Ingenuity. And that was one of the patches that had to be replaced. So, and they have a type of program that realizes that you can pull that patch out of the main programming and insert another patch right in its spot without destroying the whole program. So they tested that theory out on Ingenuity's twin at JPL in California, and they did it about 6 times and it worked perfectly. 7th time they transmitted it to Ingenuity, and the software took immediately, not 85%, Jim, but 100%. Okay. So we made it there in good time. Now, we had a similar issue with Spirit about 20 days in the flight when we were doing the software. It lost its memory completely. And so that's 2003 that we were thinking about Spirit. But the interesting situation with Spirit is that nowadays it's your thumb drives, we call them flash drives and whatever, but we had that on Spirit, a flash drive, meaning that you can erase it and put whatever you want in there. But the flash drive was completely overridden, and Spirit looked at that and said, I have no idea what to do, so I'm just dumping it. So they dumped the software, and at least it went into safe mode. So we were trying to figure out what happened with that, but because that was a new technology. So with Curiosity and Perseverance, they don't have that type of drive systems anymore, flash drives, sort of say. So the patches were written instead, so you don't have to redo memories. So it can still go into safe mode if there are issues, but you have more of a timeline to correct that, and more of a situational type of deal with what would happen to Perseverance or Ingenuity. So the new software that we learned from 2003 with Spirit and Opportunity is that now we can send it up in patches and replace it, kind of like your puzzle, Jim. We can find a specific spot that is not working that we thought. And actually it was the handover. If you remember with STS-1 and many of the other shuttle launches too, 32 seconds was the key of turning everything over from ground support to on shuttle support. So we had nothing to do with it. And sometimes you would see the clock go 33, 32, 32, 33, and then there was a hold because there wasn't a correct handoff from one point to another. And that's exactly what happened to Ingenuity. There wasn't a handoff from keeping it to stationary mode and going into flight mode. So that was the issue. So they were able to replace that patch of going from the regular mode into flight mode. So
Well, again, it's quite a technological accomplishment. You know, I think for flight, those 1.2 meter blades, which, so that's about a 4-foot blade.
4-foot blade, yeah.
Has to go at 2,537 RPM, which is a lot faster than any helicopter on Earth. And flying in this 1% atmosphere, they said, is equivalent to a helicopter trying to fly at 100,000 feet, or 4 times the height of the Himalayas, you know, which has never been done. You can't take the helicopter to the top of the Himalayas. So,
yeah, that's amazing. You look, you think of it like that, and it's like, how did it even fly?
Right.
But, you know, we were able to use the vacuum chamber and simulate all the same types of situations.
And I saw some of those early vacuum chamber flights where they tried to joystick the thing, and it would just kind of go up there, lose its balance and crash, and the blades would go flying and that. And then eventually they say, you know, we're not going to be able to joystick this on Mars, so we just have to develop the software for it to be totally computer controlled. And, you know, it can 100 times a second see if it's getting unstable or not. So flying it by computer was much better than trying to joystick it, which we can't do anyway.
Well,
so,
yeah.
Just to kind of follow up, I don't know if any of you guys are a Stephen Colbert fan or not, but he did a little joke on ingenuity. He says, I give it 2 more flights and it'll wind up on the neighbor's, stuck on the neighbor's roof. So far, you know, it's got 2 flights and it's not up on anybody's roof. So let's keep our fingers crossed that that keeps up.
Well, that's why it's software driven.
Yeah. So, you know, since we are, one of the advantages of a flying thing is you'll be able to go to terrain that rovers just can't reach. And one of those terrains are these reoccurring slope linea. I bet you guys have heard about this, but it's these lines that appear on the edges of craters. And from the pictures we see, they seem to be kind of flat terrain, but I think if this video here plays, let's see, might have to try to get through an ad here, but it really happens on very steep terrain. And maybe I'll give up on this, but you know what, scientists first thought that maybe it was like some sort of salty brine water forming these linea. Let's see if it works here. I'll try to make it big. It doesn't like that. Let's turn on this.
Here is rotating globe of Mars, and we're going to zoom in on the middle southern latitudes, the part of Mars where we find these active slope features, and zooming in on the Newton Basin crater here. What you can see are lots of gullies. The active features that we recently discovered are on the slopes that are facing mostly to the north, to the equator. What we see are much smaller scale features than gullies. You can see an area of bedrock, a steep cliff here, and it's from that bedrock that these dark features flow out. Given the latitude and the slope aspect, in particular the temperatures, it suggests that there is a volatile involved here, and the appropriate volatile for this temperature is water. Probably salty water, because sometimes these are active when it's a little bit below the freezing point of pure water. Salt lowers the melting point. And water on Mars should be salty. We know there's lots of salts on Mars. This is potentially actual water in a liquid state flowing on Mars today, not millions of years ago. And then late spring and into the summer is when these features form and fade. By late summer, early fall, they'll be completely gone, and we'll see just a normal looking slope throughout the winter. Every place where we have multiple years, these features recur. They're not exactly the same. They may be more or less active one year than another, but they keep coming back.
Okay, now, he was talking about it being a salty brine, but scientists now think it's kind of a dry dust phenomenon of, if you've ever seen a real steep dune, how dry sand can actually kind of flow down the slope. And that's kind of getting to be the consensus that it is a dry thing. And the dust storm that killed the Opportunity rover in 2018, they've seen a lot more of these RSLs occurring after a global dust storm. So it seems like it could be related to the deposition of dry dust. And so, again, if you had a little helicopter that could fly right up to these steep cliffs where these RSLs are coming from, it'd be a lot easier to study. And that's what Ingenuity is going to open up opportunity to go to that kind of terrain.
Yeah, if you put a 4K camera on a helicopter type next generation or next generation to that area, you can basically discern if it's the salty brine or if it's just their surface sand that's moving.
Right. Okay, so for our last Mars topic, China is still orbiting. They've announced that they're going to try to land probably in mid-May. So if April was the month of Ingenuity, maybe May is going to be the month of the Tianwen-1 rover. So we'll have to see what they do. They aren't real forthcoming on what their plans are. We know they're going to probably try to land in, let's see, what's it called? Utopia Planitia in the Northern Hemisphere.
That's kind of crazy because that's where Viking 2 is at.
Ah, okay.
Viking 1 is in Chryse. Viking 2 is up in Utopia.
They're up to no good.
So that's interesting.
So if they land successfully, they technically will be the third country. Russia and US have landed and put things down. Russia's didn't last very long. That's why sometimes you don't see that as a successful mission, but I think it did not explode when it hit the Mars surface. So it's technically considered a landing. But so far, the United States is the only one to put a rover down. China's rover is expected to last 90 days, which is kind of like what Spirit and Opportunity were warranted for. And there now are 8 operating orbiters around Mars and 2 operating rovers and 1 operating surface thing. The InSight lander is still going along, although they're worried that its solar panels are really covered with dust and it's having a hard time producing enough electricity to stay warm during the night. So
yeah, we need a dust devil over there.
Yeah, something to blow it off there. So, okay, that'll close down our Mars discussion, unless anybody has anything else they want to add.
Well, just looking forward to the next flights. And when they start the chemistry experiments on Perseverance will be exciting.
Yeah, do you notice they just don't seem to be doing that many press conferences and having anybody kind of like the chief scientist describe the rocks they're seeing? It seems kind of dark.
I don't think they want to take the fame away from Wright Field on Mars and Ingenuity and MOXIE. I mean, the major goals are the search for life, the amino acids, the carbon-based molecules. All of that is what we're looking for. But the most interesting thing now is let's do the experiments that we can get instant science from. And okay, we've flown Ingenuity twice now. We know it works. MOXIE works. So the big thing and the main mission of Perseverance was a search for microbial life or past microbial life. So its time is coming. But yeah, I do agree. I think they're just giving the present Ingenuity and Moxie the flag right now, so they can make sure they do that. But
yeah,
it's coming.
Yeah, I think Ingenuity still has about a week or a week and a half in the limelight here, and we'll see how they do, stretching their flights more and more each time.
Yeah.
Okay.
A couple of questions. Whoa, slow down, guys. A couple of questions.
Okay.
Number one, regarding Jezero, could we go on this on a daily basis to get a weather update on Mars?
Yes.
We can. Okay.
Yeah.
Cool. Okay.
You know, I think if you go to Perseverance's site and ask about MEDA, MEDA, you should be able to see it. I know that, you know, when we had this site up here, it kind of, I think you probably can get this kind of like a weather update. It'll probably have like maybe a wind speed and everything else.
Right. Yeah, I'm interested. Yeah, I'm interested. Okay.
Yeah. So
the other question regarding this search for life, are the scientists that secure in themselves that it's only going to be amino-based and carbon-based? What if it's something entirely different?
We wouldn't know that though.
Yeah.
We only know carbon-based. So we're looking for carbon, nitrogen, phosphorus, bunch of other little amino acids that we can that can possibly create life or past life on that. So,
is that Robbie the robot?
Yeah.
Yes, it is. Another life form. Good question, Sylvia.
So did you get that, Silvio?
Yes, I did.
Okay.
Sorry.
I get curious about stuff. What if it's different altogether? It'll blow them right, you know, walk right by.
We wouldn't know that though.
Yeah.
Yeah. It's, you know, I think all we can kind of recognize is our own type of life. Other life will be really difficult.
I'm hoping there's a commonality and everything out there, right? To bring it all together.
Well, it took 4.5 billion years to produce bacteria here on Earth, and that's the simplest form. Okay, Mars, you know, if the technology is correct and the dating is near correct, you know, it went through a wet cycle. It depends how long that cycle was to produce and the correct amount of chemicals carbon-based chemicals to be present to produce that. Now, remember, the definition of life is that it can replicate itself. So we're talking DNA, RNA, you know, we're talking some pretty heavy duty chemistry for a long time to produce that with the correct type of temperatures also. Gotcha. So, but, you know, if they're correct with Jezero Crater and all the others that look like the outflows and stuff, it's a good place to land and a good place to search.
Thank you.
Well, we'll move on to NASA topics. I want to make sure we get in this human landing system announcement of NASA going with Starship. I'm going to cheat a little bit and use a Marcus House video to kind of talk about it. He's going to talk a little bit about the Starship launching area down in Boca. So I hope you guys find it interesting. It'll maybe be about 10 or 12 minutes. We'll see. And maybe we'll discuss, or we can stop the video if somebody raises their hand here.
Into a good position in two arms.
So we'll go back to the start.
I'm about to drink some mud, and I think you should too.
Sorry for the commercial, guys, but it's the price you pay.
Orbital launch complexes in Boca Chica. We'll be discussing what each element of the complex does, how the launch complex will operate, and how it's different to other launch complexes around the globe. Huge news as well for SpaceX being awarded a massive contract with NASA for the human landing system. We covered that along with a rundown of Starship updates for the week. There is a lot to cover in this one. Firstly, the breaking news. It has only just been announced by NASA and SpaceX that NASA has selected the Starship, or a human landing system variation of the Starship that we see here, to land the first astronauts on the lunar surface since the Apollo program. This is massive news. In this design, we do see the Falcon 9-ish looking legs, as I've assumed for quite a while. So that still seems to be the most realistic leg system for Starship overall, regardless of the challenges that it imposes on the vehicle itself. We see here 4 legs as well, instead of the 6 that I thought may have been the case in the longer term. It's super exciting to see Starship form such a critical part of the Artemis program, with the contract injecting almost $2.9 billion into SpaceX with a fixed-term, milestone-based arrangement. This is huge. Congratulations there to SpaceX. Now, a quick rundown of this week's goings-on at Boca Chica. On Monday this week, Starship SN15 completed a cryogenic proof and thrust puck stress test. That all seemed to go well, with it standing up to the thermal stress of cryogenic propellant. On the Wednesday, SpaceX removed the thrust ram from underneath SN15, indicating that these tests were successful. The flight of this prototype arguably has the best chance of success yet, by building off the successes of SN8, 9, 10, and 11, and learning from each prototype's unique landing failures. That's most likely thanks to the introduction of hundreds of improvements on this vehicle. On Thursday at around 8 p.m, all 3 Raptors were delivered to the launch site, and these are the first of the new generation of Raptor that we explored in detail in last week's video. These 3 Raptors are SN54, 61, and 66. Hopefully none of these let us down this time. This prototype is likely to be able to attempt a static fire this coming Monday, April the 19th. If this test is successful, we could see the next flight as soon as Wednesday, with Elon Musk here tweeting that SpaceX is aiming to launch its 5th high-altitude Starship test flight as early as next week. At the build site, SN16 stacking commenced on Wednesday, with the common dome being stacked onto the middle liquid oxygen section here. Then promptly on Thursday, the forward dome was then stacked on top, meaning that SN16 is now standing at 10 rings high. Interestingly, on Monday, BN1 was cut in half, with the top section being picked up by the gantry crane and brought down to ground that night. Since then, both halves have been taken apart and sent to the scrapyard. Then we saw BN2's forward and aft domes sleeved. What I want to cover today in more depth, though, is the development of the complex itself. Big shout out to Mauricio from RGV Aerial Photography and Mary from NASA Spaceflight for these images, giving us the chance to see these amazing developments as they happen. We can't cover things like this without them, so please do go and support both of them if you can. Now, construction at the Orbital Launch Complex first began in June of 2020, with the very rapid development being made for the foundation and the 6 support pillars for the orbital launch pad. In fact, development was so fast that the site just seemed to appear from almost nowhere in between the flight videos that SpaceX uploaded for SN5 and SN6's flight. It was honestly crazy just how much development was taking place. But then fairly shortly after that, development seemed to almost stop. It's not currently known why the construction seemed to cease, but it's speculated that SpaceX switching its focus to the testing campaign of the SN8 vehicle may have had influence on it. To further support this argument, just a week after SN8's extraordinary test flight, production ramped back up again, and it's only really gotten faster since, with these latest images showcasing just how much progress has now been made. Now that we've covered that, we can move on to the detail of the complex itself. We're going to start at the pad and work our way outwards. Our screen now is a render of what the pad could possibly look like, made by the amazing OBL on Twitter. It is important to note here that this is just an idea of what the pad will look like using the parts that we currently see at the Boca Chica construction site, and nothing has really been confirmed that much by SpaceX. The main part of the pad that we see here is the launch table. This is what the vehicle will sit on prior to launch itself. Unlike most launch pads, this will also have the fuel lines that will attach the vehicle prior to launch. This is because Starship has to be filled from the base to allow for orbital refilling as well. The pad will also likely have these sorts of launch clamps that will hold the vehicle down until the massive beast is ready to lift off. This is important because if the engines ignite but then need to be shut down quickly, like we saw with SN10, the vehicle can remain safely on the pad. That is obviously much better than, hopping up slightly and then crashing back down to the pad, destroying the vehicle.
Poor Vanguard.
Now, this isn't a new idea, of course. Almost any launch facility has this, but it's good to note just how we see those mechanisms working. It was thought that this mysterious structure currently being constructed at the Spacex shipyard in Boca Chica could be part of this clamp mechanism, but it now appears that this is more a device for testing the pressures the nose cones can take. That is not confirmed by SpaceX at this time, so we'll just have to wait and see what happens. Thanks a heap, everyone, for some of the feedback on that structure, and of course for liking and sharing these videos. That really does help get this work out there, along with, of course, subscribing to the channel. Everything we dive into, such as this topic today, is all possible thanks to all of that support. Thank you for helping us out. Now, you may have also noticed that unlike most launch pads, the pad in Boca Chica does not currently include a flame diverter trench. This would usually be an angled slope of some sort beneath the pad so that the ground beneath does not take the full force of the thrust that the engines create and throw debris back towards the rocket. At pad 39A in Kennedy Space Center, this is a large concrete structure that ramps upwards to create room for an angled slope beneath the pad itself. At Site 1 of Baikonur Cosmodrome, a giant flame trench was created by digging a trench in the ground. Elon Musk has said that SpaceX doesn't plan on using a flame diverter for the orbital launch pad, so we can assume that they will use a water deluge system similar to the ones that we've seen on the current suborbital test stands in Boca Chica. Seeing that a flame diverter-like system appears to have been installed at the Starship pad in Kennedy Space Center, SpaceX may have just changed their mind on this, at least for the booster. What do you think, though? Should SpaceX use a flame diverter? Let me know in the comments. Heading away from the launch pad, we can now move to what is possibly one of the most exciting features of the orbital launch complex in Boca Chica. That is, of course, the 450-foot or 137-meter launch tower and catching arm. This launch tower is going to be absolutely crazy, rising up high above the Boca Chica beach. The launch tower has three main functions. The first function is a way of transporting crew members from the ground into the vehicle itself. There will likely also be an elevator and a staircase leading up to the small room that connects to the crew access arm. This is a small corridor that bridges the gap between the tower and the door to the Starship so that the crew can cross and board the vessel. This, we think, is likely going to look a little like the crew access arm at pad 39A that is used for boarding the Crew Dragon. Once the crew are on board here, the arm just swings away from the Falcon 9. This is done just prior to the Dragon spacecraft launch escape system being armed and the fueling taking place. In this launch animation, we get a good idea of what one of SpaceX's Starship towers are going to look like. It is likely that this is how the tower and pad area will look, because as we can see from these images by Mauricio, the tower and pad are being constructed at the same position as seen in the render. Maybe the launch table at the construction site will have more pieces welded onto it so that it looks something more like what we see in the render here. Or maybe SpaceX will go with a different design entirely and will use a standard steel girder type structure. I think that the latter is actually more likely in the short term, at least for the initial launch pad. The second function of the launch tower is to stack Starships onto the pad itself. Now, this will be a fairly strange task for the launch tower to do, as usually this is only here to provide fuel to the vehicle, hold the vehicle down, and provide that crew access. The reason the tower will be used to stack Starships on the pad is to help with the vision of the Starship being rapidly reusable. Instead of having to wait for the vehicle to first be safe to approach, followed by, of course, rolling a crane down to the pad to stack it manually, you can land the Starship and then use the tower to stack it back onto the Super Heavy booster very rapidly. Because of this, the vehicle will be reconnected to the plumbing and the tank farm so that SpaceX can drain the remaining fuel back out and store it for a future launch. If they instead needed to wait hours for the fuel to drain or boil off before approaching, the fuel is essentially wasted along with all of that time. Remote stacking systems will save a lot of resources and hours to really help push towards the goal of a Starship being fully and rapidly reusable. The final main function of the tower is by far the craziest one and also kind of the coolest. I'm, of course, talking about the giant catching arm that will be made on the tower. This arm will be used to catch the Super Heavy booster right out of the air so that the booster doesn't have to land back on the landing pad itself, meaning that SpaceX can scrap those 4 gigantic legs that they were originally planning on using. We still expect, of course, that they're going to be using legs in the initial prototypes that we're seeing rolling out now. But in a longer term scenario, this will save a huge amount of weight, which will of course equate to more payload in orbit per launch. As they say, the best part is no part. Now, it is obviously unlikely that SpaceX are going to be catching these boosters in the short term, but as seen in this image from Mary, you can see from the label BN3 is going to have 4 landing legs. This is so that SpaceX can have more time to figure out the best design of that catching arm and, of course, to develop the entire system. They won't fully know how the Super Heavy booster will perform until they actually fly it. Perhaps it will be BN10 or above that will be the first booster prototypes without the landing legs. So the way this catching system will work is that the booster will descend down towards the tower and then hover for a moment to adjust itself into a good position. Then 2 arms of some sort will get into position around the booster. This will allow the booster to slowly descend into the arms using load points beneath the grid fins to take the weight of the booster itself. Now that is going to be an awesome sight to see. So depending on how the tower is designed, the booster will be either lowered directly back onto the launch mount, or maybe the tower will swivel in some way before lowering the booster. The latter method has the advantage that if the booster catch fails, the booster won't destroy the launch mount itself. So now for one of the features that we probably have the best idea about. This is the tank farm at the Orbital Launch Complex. This new tank farm will look vast.
Well, you know, how do you guys feel about catching boosters in midair?
Well, it doesn't land in the same spot on the landing pads at Kennedy. It's going to be quite a challenge. It looked like it was no more than 24 inches away from the tower when it on the animation.
Yeah.
Just like you, Jim, I was surprised that they actually went with that that Starship system. But the big question is, will it be ready by 2024?
Well, Musk today said it could happen. You know, the bigger issue will the SLS be ready to launch for the 3rd time by 2024?
I'm trying to get a handle on grasping the macro physics involved in what we're talking about. So it takes what, 25,000 miles per hour to get to the moon. We're talking deceleration. And
7 miles
it'd
per
be
second.
easier to land on the moon. Again, I'm trying to grasp whether or not they're going to do the Apollo approach, similar to that of a lunar lander, or are we looking at one piece here?
They're looking at one piece.
Yeah, that was their proposal. One piece.
You know, we showed the Super Heavy first stage with Starship on top of it. That's the general architecture that SpaceX is coming out with. But those Starships come in a lot of different flavors. There's going to be tanker Starships. There's going to be man-carrying Starships, and then there's going to be lunar Starships like this white one shown here. The $3 billion fixed price contract that SpaceX signed with NASA is to fly one of these unmanned to land on the moon, and then to try to come back by 2024. And what you would do is launch one of these from the Earth. NASA would launch an Orion capsule with 4 people to the moon. In lunar orbit, the Orion would dock with this lunar Starship, transfer 2 of the astronauts to the Starship. Those 2 astronauts would land on the moon for a week, take off from the moon back into orbit, dock again with the Orion capsule. All 4 astronauts would get on Orion. Orion would bring them back to the Earth. That's what the contract is to demonstrate. Those 2 flights, once unmanned and once manned landing.
Well, they
Amazing.
definitely have a Ramada in there, that's for sure, compared to
Yeah.
Oh yeah.
compared to the LEM that Apollo had.
So in the model we see here, Dean, how much of the chassis takes fuel capacity and other for living quarters?
The bottom 2/3.
I think
2/3?
everything up to this black
Yeah,
mark is
is
probably
all
fuel
fuel.
tanks.
Yeah.
Wow.
Up to the blue.
It's amazing if they can pull this off.
I would agree.
Yeah, you know, it's one thing, you've got a crane that has to bring the astronauts down 30 meters to the surface. If you notice, they're probably kind of on a cage mechanism here that actually winches up all the way to here. The other thing is a lunar starship has its thrusters way up here so it doesn't kick up half of the dust on the moon and put
Right.
that into orbit.
I
It's
think
a
they should
kind
put a ladder there just in case.
yeah, there's got to be a backup in case.
Yeah, I know.
Yeah.
I'm having trouble with this.
2 words, jetpack. There you go.
Yeah.
Yeah,
Arr, 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 arr.
that has possibilities, right? Yeah.
Yeah.
That would be cool.
That would kick up too much dust. You wouldn't be able to see the entrance.
How about just a winch? They'll push the guy out and they'll lower him by.
Well, it is 1/3 gravity. I agree. Yeah, maybe yeah, it'd be a little different. Yeah,
Well-
it's a lot of development there, Jim. What do you think?
You know, I thought for sure, just for a competition's sake, they would have kept 2, but I can understand that SpaceX was definitely the lowest price. Congress didn't give NASA a lot of money for development. So NASA was kind of playing hardball, I think, with Congress and said, okay, if you don't give me the money, I'm just going to pick the lowest price bidder.
Oh, yeah, that's not always the good thing.
So where does the SLS fit in all this?
Well,
Well,
the SLS isn't designed for the moon. It's designed for travel to asteroids and the planets. That's why we have the commercial crew system. You know, I think Orion can actually dock with the space station, but that's not its primary intention.
right. But again, SLS and Orion are part of the landing. They get the astronauts to the moon and back from the moon. HLS will just take it out of lunar orbit to the surface.
So we're gonna have a
So
lot of spent boosters on the moon, huge ones.
yeah, you know, I'm sure we haven't heard the last of this. It definitely was a bolt out of the blue. I thought SpaceX was in a race, was third in a race of 3, and here they turn out to be the only awardee.
Yeah, I like Dianetics actually.
And what I couldn't understand about Dianetics is apparently it was even more expensive than the
Yeah.
Blue Moon lander.
Right. It was the most expensive, but probably the only one that actually had the astronauts get down a little ladder like the LEM. You know,
Right.
even Bezos's lander, you was quite high to get down also. But this
Right.
is I don't know if I can go out on a limb. This is still science fiction.
Yeah, you figure
Feels like that, doesn't it?
It does.
yeah,
I mean, unfortunately, I don't want to be a pessimist, but it's 2021. He wants to test this thing by 2024. He's got to quit exploding these rockets in Boca Chica.
Oh, yeah.
right. SN15, I think now is scheduled to fly by the end of April. So we'll see how he does. Now, you know, it's a controversial decision. I think the document that described why they picked only SpaceX is pretty flawed. You know, we're going to hear a lot more about it. Here, let me play NASA's video related to maybe what they did and that.
importance of landing humans back on the moon is we're going back in a way that is totally different. We've had almost 60 years of experience, and we're taking every single ounce of experience we have and taking that with our international partners, with our commercial partners.
We've been working for the last year with 3 partners who will help us achieve the next human mission to the moon. Because we know that this first step to the moon will then lead us to go to Mars. And we know that the human landing system is one of the first steps to get us there. And so we've been working with Dynetics, Alido's company. We've been working with Blue Origin, who have partners of Draper, Lockheed Martin, and Northrop Grumman. In addition, we've also been working with SpaceX.
This is a very, very exciting time for the Human Landing System program. They've spent a lot of blood, sweat, and tears over this last couple years getting ready for this moment.
We're really excited to bring you the announcement of who NASA is going to continue to finish out the human landing system and take humans back to the moon. NASA has chosen SpaceX to return us to the moon. I am so excited to partner with SpaceX in this fantastic endeavor for the Artemis suite of missions. So congratulations to the SpaceX team. SpaceX design is a single-stage solution using their Starship. It provides extensive volume for the crew with 2 airlocks and ample down mass capability. The SpaceX proposal included in-space propellant transfer demonstration and uncrewed test landing. So now that we've selected our partner, and for the next phase going forward, we have to make sure that the testing occurs, because we're not going to launch humans until we have a successful test. So we will be working to make sure that the design and everything that we have going forward so far is ready to go.
So the human landing system is going to allow us to be able to access different parts of the lunar surface. But it also allows us to explore a new technology and capabilities that will help us when we are trying to figure out our next round of technologies to be able to help us land on Mars or other planets out there.
I'd like to thank the companies for the great work this past year. We've all learned a lot. I'd like to thank the NASA team, because you have definitely risen to this challenge.
It is one more step, an exciting group of steps that will get us to a sustainable human landing system to the moon.
So what does this say about Gateway then?
Well, Gateway will come later, but not right away.
I don't see Starship docking with Gateway.
Let's see.
I see Orion docking with Gateway, but I don't see Starship docking with.
I think there's no technical problem that it couldn't, but
what kind of number is that?
The Starship will be, 3 times the size of Gateway when it docks.
Yeah,
so they have to watch their inertia.
Yeah, that's true. Again, NASA was very forthcoming that this $2.9 billion are for these 2 flights, an unmanned one and the first manned landing. They reserve the right to then go back out and have other companies contract for other landers. So it's not a done deal, but I think people thought that NASA would have to spend $21 billion to develop these landers, and they're getting it done for less than $3 billion by going with SpaceX right now. So that's bottom line, I guess, why maybe this decision was made.
Yeah, well, we'll just have to see. So, I mean,
Yeah.
I want to see it, but I'm having trouble with the concept of launching and landing SpaceX.
Yeah, I know a lot of people are still scratching their heads, so the jury's out as to whether the prudency of it. I also was surprised that they were doing it, making the announcement the week before they got their administrator nominated and affirmed. So, we'll see.
Yeah.
Again, just to maybe show a little bit of in that video, that background video, I just wanted to kind of tell everybody that, SpaceX is doing a lot of this on its own dime.
Right.
And again, this is a fixed price contract. So,
SpaceX may figure they were going to do it anyways. So
right.
They now just got funding. I mean, on their side of the coin, they may say, hey, look at all the money they gave us to do what we're going to do anyways.
Right. So now they got $3 billion to kind of help them along. But what I wanted to show you about that Boca Chica is that there's just a lot happening. And here's SN15 that might fly the end of this month, but they're working on 16, 17, 18, 19, and 20, plus super heavy prototypes, the first stage here. So just a lot happening. If anybody could do it by 2024, SpaceX could. But
yeah, I agree.
I've also experienced Elon Musk time too. He'll say he's going to do something by the end of the month, and then 3 years later, you're still waiting for it. So we'll have to see.
That's what happened with Dragon or Falcon Heavy. It was took a little while to get that straightened out.
Yeah, I think Musk really underestimated the amount of engineering he'd have to do to put those 3 cores side by side. And, he had, big dreams of cross fuel between all 27 engines. That never materialized, but, we'll see where we go.
Right.
So getting back to a new topic here, budget came out of Biden. He's going to request an extra 6.3% increase for NASA. So he's 24.7 billion, which is 1.5 billion more than what NASA got last year. So, that's good news. You kind of compare it to Trump trying to get a 12% increase for NASA a year ago, but that never materialized. Congress didn't go for being that loose, I guess, on the budget.
Well, this is the problem you have between government and commercial contract. When you have government, you've got a $460 billion military budget, and you got a $20 billion civilian NASA program. It sounds simple enough to transfer some money from the military budget over to the civilian budget, but obviously no one has tried to even do that to see what would happen. But that kind of points in the direction of where our priorities are. If you've got a $460 billion military budget and only a $20 billion civilian budget,
it's even bigger than that. I was gonna say the Department of Defense budget is 700 and I think it's It's gone up from 704 billion to 715 billion this year.
And most of it is R&D, I'm sure.
Yeah, and that's 30 times what NASA gets. So, you know, put it in perspective.
Yeah, I don't understand why a simple $25 billion transfer would impact the $750 billion budget for the defense.
Right.
Yeah.
I mean, how many more nuclear bombs you need? How many more fighter jets you need? You could do it. You know, how many more?
Yeah, but
put somebody on the moon, then you'll see how fast that budget grows.
Well, I agree with yeah, definitely. That's definitely the pushing point. I mean, we've got, you know, China roaming the other side of the moon right now. I mean, and then they're about to land on Mars. I mean, if there's any catalyst to move us a little faster, there may be transfer, but I don't even know if that is even feasible to transfer money from the defense, and what eyebrows would be raised in situations like that. This is why commercial crew is good, because the only eyebrow that's going to be raised is Elon Musk going, let's just do this now, you know, without any red tape. I mean, that's the difference between government and commercial crew. That's why he's able to do tests and move. The only thing he has to do obtain FAA licenses to launch. So yeah, we'll see.
Dean, you would think it'd be easier because remember, former President Trump took the money from the military budget to build his wall, and they didn't really complain about that. So what's, like you said?
It depends on the purpose. I mean, it depends on the purpose. I mean, NASA's never been in the limelight. Immigration has.
Right.
So you have to pick your wars, sort of say, from, and that's the problem. You know, our administration changes every 4 years in the priority. Remember, Obama, we were going to go visit an asteroid. We weren't even going back to the moon because Obama said we were there already. You know, so there's a lot of things that go on government-wise. So we should just be thankful that we're able to do the commercial crew and it's funded.
Yeah, so we'll see how Biden's request for NASA gets treated by Congress. The one good thing I liked hearing is he was all for supporting STEM education, which I think, again, is the way we're going to inspire the next generation to get involved in science, engineering, and all those good things. And he isn't trying to do a 180. He's not completely walking away from Artemis, but I think Artemis has got to move relatively quickly without asking for big extra amounts of money. So
yeah, I agree.
Let's all hope that big core that they tested down in Mississippi is on the barge heading to Florida now. So it should be started to be integrated, and maybe they'll still be able to launch that first SLS this year.
That would be great to see.
Yeah, and the other good thing is there was a whole bunch of new telescopes. The Nancy Grace Roman Space Telescope, that's kind of a new Hubble-sized instrument, got funded where it was canceled completely by Trump's last budget. So it's got a lot of good things in it. I think it seems like he's putting the money in good places. So we'll see. Well, hopefully it'll be able to move. I saw Bill Nelson, the nominee, testifying, and just about everybody was saying good things about him. I never heard Ted Cruz say good things about anybody, but he liked him.
Wow.
And Marco Rubio was saying good things about him. So I heard he's already been confirmed.
Oh.
You know, that might be a little premature. I don't know where I heard it, but I'm pretty sure he is. So it's just glad we're not going to be arguing about who heads the organization.
Right.
And then Pam Melroy, which is another, I think, solid pick, is going to be second in command at NASA. She's going to be the deputy administrator right next to Bill Nelson.
And they're still going to keep the Space Council also.
Yes,
Yeah.
Which I think is a good idea.
Yeah.
Yeah. You know, some of the meetings of that were a little disappointed. They're so military centric, but I hope NASA can kind of keep an arm's distance on the militarization of space. I don't think that's the way the world wants us to go.
Well, for a civilian agency, they better not.
Yeah.
So in tradition, hasn't the vice president been kind of the liaison?
No, they've been the head of NASA. The vice president is the head of NASA.
Is the head of NASA.
Kamala Harris is.
Yeah, because I haven't heard much from Kamala Harris on NASA. Have you guys?
No, I think she's not going to be as hands-on as Pence was. But, you know, again, I don't know if we have to go all the way up to the vice president, but as long as the White House is listening and giving good direction, I think that's adequate in my mind.
Yeah, the Space Council is good. It orientates your priorities.
Okay, so I'm going to move on to a little bit about Crew 2 today. I got up at 2 o'clock and started watching. I'll admit I was sitting in my lazy boy and I don't think I was awake the whole time, but they did launch. And this is the four kind of veteran astronauts all going up. Megan MacArthur is the pilot. Shane, let's see, Shane Kimbrough here is the commander. And then we've got a Japanese astronaut and a European astronaut from France, Thomas Pesquet or whatever. So a good mix, international. The interesting thing is Megan is the wife of the guy that flew on the DM2 test mission.
Yeah.
So, and they're reusing the capsule from the DM2 mission. So she's actually sitting in the same seat that her husband sat in the spring of this year. And NASA agreed to have SpaceX use a reused Falcon 9 booster. So the Falcon 9 booster that launched these four people into space was the booster that launched the Crew 1 mission that's up there now.
Very cool.
So on one rocket, we've got 2 Dragons and 8 people up on the space station, which, you know, is coming a long way. You figure 3 manned missions now for SpaceX. They've launched more astronauts than were in the Mercury program. Our first astronauts, now that they launched 10 people. Yeah. So it's just coming along amazingly. This was the 11th launch for SpaceX this year, and they landed the core again on the drone ship. So it was their 80th core landing. So they've done it 80 times now. And it should dock tomorrow morning, and we'll have 11 people on the space station. Some of the people are going to have to sleep in the Dragon capsules because there's only 7 sleep stations, and we'll have 11 people on the ISS.
The Dragon looks comfortable.
Yeah. So it's not a record. I guess the record is 13 when the shuttle was flying, but a lot of those astronauts could spend their time back in the shuttle. They didn't have to really spend all their time on the ISS. So we'll see how it goes. But commercial crews really taken off, at least on the SpaceX side. And then here's our logo for Crew 2.
Very cool.
I guess always a different colored dragon. Yeah. And the 4 names here. And just to give you a little feel for it, they gave a little tour of the Dragon. I heard on the ABC News tonight that a piece of space junk Yeah, missed the Dragon capsule by a few, maybe 100 feet. I hadn't heard any of that from NASA, so.
Oh.
Yeah, they said they got them suited up and everything.
Yeah, yeah. So apparently it happened right after they gave this little tour inside the capsule.
And there he is.
Wow, that's an interesting tour.
Well, there's a lot of room in that capsule.
You're gonna have to do some editing to get these commercials out, Keith. But here's Shane and Megan, kind of up with their touch screens.
What a beautiful spacecraft.
Kind of Eastern. So everyone, welcome on board Endeavour. We're a couple hours into the flight.
Are they,
you guys hear that?
Sure seems like they're cramped.
Turn it up a little.
Africa. So it's really great looking out our windows, and we get to see some pretty cool stuff up here. But we had an incredible launch. Hopefully you guys get to watch it this morning. Right as the sun was rising, we took off. We chased the sun pretty quickly and caught it up just a few minutes after we took off. That was pretty special to see the sunlight coming in shortly after liftoff. We're going to show you around the vehicle real quick. I hope you guys really enjoy it.
That's okay, Jim.
Yeah, I think it's maxed out for me. So it's surprising how much room they've got in here.
To be back in space again after a few years for me. The ascent was incredible. The ride was really smooth. We couldn't have asked for anything better. There may have been some hooting and giggling up here while all that was going on. We hope you enjoyed the show as well. I'm kind of relearning. I'm like a baby bird here, relearning how to move around in microgravity. It feels really good, but it feels a little bit weird too. Fortunately, it's a nice small space.
I love those flat panel consoles.
Yeah.
So modern. It's amazing.
A little bit of what up here.
Yeah, it certainly doesn't have 250 miles of wiring like the Apollo capsule had.
Your tour guide today in the Crew Dragon Endeavour capsule. Thanks for flying with us. Welcome.
It's great. It's great seeing this because it's so roomy compared to the Apollo capsules. Oh my gosh.
Yeah.
And next will be Akiyoshi Day. So
Seem comfortable. Yeah.
The ride up was fantastic. This is the hatch behind it. The space, harsh temperature, that environment, that stuff. Inside, very comfy. We feel very well protected. Everything is great. If you get closer, you can get a view out the window, and I'll try to give you that. If the cable's long enough, and this is what we get to see.
Very cool.
That is cool. Send that to the Flat Earth Society.
There you go.
And I can show you maybe the cargo area down there, because these vehicles bring people up to space, but also cargo. And if you follow,
I heard the word Chicago.
No, I think he said cargo.
Oh, cargo?
Yeah.
freezers. This is our suit, nicely packed. This is for more cargo. We have more water landing equipment. This is all nice and tidy. And behind those walls are a lot of other equipment that we need: clothes, food, and etc. So we
Almost gives you like an inside airline feel, you know? Airplane.
Yeah.
For short, from JAXA, and he's going to give you some more information. Hello, Erwin.
Yeah, I think the video breaks up. They might lose the connection for a little while. Let's see. I'll fast forward to.
Yeah, that was a nice tour. What a beautiful spacecraft.
Definitely.
Tomorrow, Aki talked about we're going to dock to the International Space Station. It's going to be around 5 a.m. Eastern time in the U.S. So if you guys
Are you going to be up at 4, Jim?
Yeah,
probably.
If I'm awake, I just may do it also.
A couple Russians and Mark Vandehei. So we're looking forward to joining that crew and having a big time up there with 11 people on board. Megan, any closing words?
I think their zero-G thing is a little penguin.
Yes.
So when are they docking?
Tomorrow morning at 4.
Through all the different phases of flight. So we had displays up, of course, during ascent, and then we'll have some ability
ability to monitor the docking sequence as well. All of the
I still have the docking game set up on our MASSCosmos if you guys want to try it again.
Yep.
The space station on our screens as we get closer. And then, of course, once we contact the space station, we'll monitor the docking system mechanism using these displays as well. So it's pretty neat to see the touch screens and all the different facilities that they have. We can bring up different systems pages while we're working through the different activities. So those are something neat.
That's amazing, isn't it?
And the old-timey steam gauges, we have these pretty cool touch screens that we can use.
Hey, Hank, we got to maybe have a special episode where you can show your flight simulator stuff.
Yeah.
He's got the latest and greatest. It's very cool.
Yeah. If I can get it to work.
We all rushed to the window to look at that for a little while. So that was pretty cool. So we're enjoying our first day on orbit. So we got a lot more to go, and we're looking forward to it. Hope you guys enjoyed the little tour of our capsule. And we'll be in a much bigger environment tomorrow once we dock with it.
So, Jim, is that 2 Dragons at ISS now?
Yes.
That's, wow, that's going to be something.
So they're going to use both of the international docking adapters there. You know, and that's a little, reason why Starliner can't launch, because the Starliner needs one of those too.
Right.
And as soon as Crew 1 is supposed to come down April 28th. So I think they'll be on orbit probably 160 days by that date. And, they've really crushed the American launch time and space record. The oldest was 84 days by a Skylab crew, and they're going to be up there 160 and almost double that.
Yeah, Carr Gibson and Pogue.
Yeah,
Skylab.
So amazing. So, we'll keep our fingers crossed. There's only going to be about 4 days, and then they'll hand off, and the Crew 1 will come down and land. NASA's got a lot more Coast Guard boats to keep all the crazy people away from the capsule.
Yeah, that was crazy the first time.
Oh, yeah.
Who would have anticipated that, huh?
Yeah. Boat right up there. Yeah.
So we're hoping everything goes well for the landing. I have a feeling they probably won't announce the coordinates that much. That way nobody can make it there in time.
Oh, yeah.
That's probably a good idea.
If they're a little farther out, too, it makes it a little more difficult. They were nice and close, so you could get to them,
Right,
yeah, right. So, okay, I'm going to move on to another subject. It's kind of interesting, this Psyche mission. It's going to be, it's going to have Hall thrusters, which are a souped up ion thruster technology that so far no spacecraft has done. But the Lunar Gateway, again, is going to use these kind of Hall thrusters to kind of maneuver itself around the moon. And I think it's going to be a big thing there. They cut down on the amount of fuel that they need to go to this asteroid Psyche. They cut the fuel down by a factor of 5 by using the ion thruster technology.
That's nuts.
So, one amazing thing is they think Psyche is just like a bare piece of a core of a much larger asteroid. And they said all the rare earths and metals on Psyche, if you added them up in the market value, the asteroid Psyche is worth $10 quintillion. And if you guys aren't up on quintillions, a million is 1,000 thousands. A billion is 1,000 millions. A trillion is 1,000 billions. A quadrillion is 1,000 trillions. And a quintillion is 1,000 quadrillions.
A lot of money.
How do you know that?
Well,
holy cow.
Yeah. I go all the way up to vigintillions, which is 63 zeros.
That's amazing.
Yes. So So it'll be a very, very interesting mission. I can't wait to get pictures of what this Psyche asteroid looks like. I think it's out there kind of almost in a Jupiter area type orbit, and that's why they need this thing here with the real powerful Hall thrusters. They think they'll be able to get this. It'll be launched on a Falcon 9 rocket, and then the Hall thrusters will boost it out to Psyche. Maybe it'll get out there around 2026, something like that. But again, it turns electricity into shooting your fuel out at enormous speeds because it gets heated to very, very, very high temperatures and ionized. So that's where the efficiency comes from. And it's not a tiny spacecraft if you compare it to people here. It's, 2 or 3 times the height of a man. And the
solar panels are huge too.
Yeah, solar panels are huge because you need a tremendous amount of electricity to try to power these Hall thrusters. So we'll keep our fingers crossed. I think that's launching pretty soon. Let's see if I got it here. I don't see it, but
what's the travel time to Psyche?
Yeah, if I knew when it was launching, then it gets there in 2026. Let me see if I've got that anywhere here.
Is the technology for the ion drive still viable?
How do you mean ion drive there?
Didn't they have a big push for ion drive technology way back when?
Yeah, and I think that's a little bit where these Hall thruster technology is coming from, because it's taking like the ion drives that the Dawn mission had and them way up. So it's getting much more capability. So I bet you, it's due to launch this coming summer, next summer.
Very nice. Very nice.
Falcon Heavy rocket. So we'll keep our fingers crossed, keep our eye to the ground on that one. And then the other thing I want to talk about a little bit is Bennu is getting to say goodbye to, or OSIRIS-REx is bidding goodbye to Bennu.
Yeah.
And it's amazing. If you look at this diagram here, you can slide this to see what it looked like before and what it looked like after the probe punched in here to get the sample. And there's a little short video here that, let's see what it has.
Like blueprints on the moon, NASA's OSIRIS-REx spacecraft left its mark on asteroid Bennu. Now, new images taken during the spacecraft's final flight on April 7th, 2021, reveal the aftermath of the historic feat. The spacecraft flew within 3.7 kilometers of the asteroid, the closest it has been since the touch and go or TAG sample collection event on October 20th.
Look at the detail, that's nuts.
During TAG, the spacecraft sampling sank 48.8 centimeters into the asteroid's surface and simultaneously fired a pressurized charge of nitrogen gas, churning up surface material and driving it into the collection chamber. 4 of the spacecraft's backaway thrusters launched rocks and dust during the maneuver as OSIRIS-REx pushed back off into space. Multiple sub-meter boulders were mobilized by the thrusters into a campfire ring-like shape, similar to rings of boulders seen around small craters blocking the surface. The spacecraft will remain in Bennu's vicinity until departure on May 10th, when the mission will begin its 2-year return cruise back to Earth. Ultimately, it will deliver the collected sample to the Utah Test and Training Range on September 24th, 2023.
What a successful mission that was. How exciting.
Yeah. And the amazing thing,
blueprints on the moon.
Whoops, sorry. Is it actually, if you guys heard it, it actually penetrated 20 inches into the surface of the asteroid. So I think that's going to define walking on an asteroid isn't going to be that good, because it's going to be like trying to walk on a thick snow without snowshoes. You know, you're going to
That's a good reference.
Yeah, asteroid shoes to not fall right into it.
Well, maybe it's just me, but that capsule that came down in the demo, Look a lot like the Astronomy strain capsule. Right?
Hey, don't go there, Keith. That was a good movie.
I love that movie. That is awesome, actually.
Yeah.
The original now, not the remake.
Yeah. No,
original always.
Yeah.
Have to have
well, now
no.
I know we're getting tight on time, but I really wanted to talk about this because I don't know if I can remember what I've read in another month. So
is this from Fermilab?
This is Fermilab's muon G-2 experiment here.
Right.
So it's really interesting to have this cutting edge physics test done locally here. And you can see this is the magnet that they used to do the experiment. The cool thing is they actually brought this magnet all the way from Long Island, New York to Illinois. They took it down the Atlantic coast and then up the Mississippi River, barged it up close to the western suburbs here. And then I remember a few years back, the highways being closed, because bringing this down I-88 really caused a little bit of a stir.
Yeah.
But they installed it at Fermilab because Fermilab had the ability to create a lot more muons than they could at the Long Island accelerator. And the whole point is the muon is a 200 times heavier than the electron, similar particle to the electron. It's got a charge of minus, and because it's heavier, it's more susceptible to this wobbling of its magnetic field. And what they did is they did this phenomenally sensitive model. If you look at these numbers here, the standard model predicts that the muon wobbling factor is going to be 0.00116591810. On their experiment, they found that it's actually 0.01116592061. And that's 4.2 sigma apart, which is it's like 1 in 100,000 that this is just purely accident. And the physicists are just going berserk. This is like one of the biggest things that ever happened. What they figure when they calculate this number, they're calculating, they calculate like 10,000 Feynman diagrams of all the possible virtual particles that can exist in a vacuum. And the fact that these two values differ, there might be an unknown hidden particle that's affecting how the muon wobbles.
Yep.
And anything that predicts a new particle gets the physicists really up in arms there. So
I heard it's a possible tie to dark matter also.
I heard that too, which has gotten me really excited too.
And may I also say that it's nice to put Fermilab back in the news again.
Right.
Yes, definitely.
Yeah, you know, Fermilab's got this going, and Fermilab's got a lot of neutrino research where they're shooting neutrinos to a gold mine in
Minnesota.
Dakota.
Dakota and Minnesota. Yeah, they're just bombarding our northern states.
So, you know, there's a lot of interesting science still going on there. So, you know, it's just amazing. And in my notes, I'm going to put a couple references to a couple of Lawrence Krauss YouTube videos where he explains it. It's really interesting to see Lawrence Krauss try to do it. He's not embracing technology. He still holds a paper pad up with his hand sketched diagrams. He will not digitally draw anything. He's still working with a paper pad, but I give him credit. And between his two videos, he said he went out and had a margarita and came back and actually was still able to be understood. So he's kind of a hero of mine. So
yeah. Mine too. He's got a great book. The Universe from Nothing is excellent read.
Yes, yes. So keep your ears to the ground for the muon 2, what did they call it here? Muon 2 minus or G minus 2 experiment here. So great physics happening in our backyard here.
Fantastic.
So let's see. I know we're getting close. Maybe I'll edit a little bit quicker here. How you guys doing? Can we go for another 15, you think? Or?
Sure, yeah.
I cannot.
Okay.
I'll have to log out. Thank you.
Well, you know, if you can't, I bid you a fond farewell. Remember, you can always catch it either in recorded mode or notes on our website there.
Thank you, gentlemen.
Okay.
Thanks,
so
we'll switch to a couple of quick astronomy topics here. I just wanted to talk about TESS. TESS is the satellite that kind of took over for Kepler, trying to look for exoplanets. And after a couple of years of operation now, it's found 2,241 exoplanet candidates. So, you know, what TESS sees as a dip in the light of the star, they're looking for larger Earth-based telescopes to actually look at the star and see if they can see a Doppler shift of the star moving towards and away from us that matches up with the light curve that TESS sees, and that way they can confirm it truly is an exoplanet.
All right.
But the great thing about TESS is it's looking at bright nearby stars in the entire sky, whereas Kepler was looking primarily at stars maybe 1,000 light years away, which are hard to follow up if you're going to try to maybe look at their atmospheres and that.
Yeah, so, Kepler was also in one designated area also.
Right. So these TESS candidates are going to be great for the James Webb Space Telescope to use for studying exoplanets. So
yeah, and that's due to launch in Halloween this year.
Yes, so it's kind of right around the turn here.
Coming up.
And another thing I saw on a Neil deGrasse Tyson show was this periodic table kind of for an astronomer. And let me find the real big one here. And I think if I look here and then go here, I can get it nice and big.
Yeah.
But
cool.
You know,
very nice.
You'd think all the elements kind of would be just a single process going through time. You know, the Big Bang converted a fourth of all these hydrogen atoms into helium atoms. So really the Big Bang only did these two elements, hydrogen and helium. And then to form lithium, you had to get into cosmic ray work. And the nice thing about this diagram is it not only shows the amount of atoms that come from the different process, that there was a tiny slice of Big Bang creating lithium, but and then a piece of it comes from cosmic ray fission, but then the yellow shows that dying low mass stars are the major formers of lithium. And then beryllium gets back to cosmic ray fission. I think that's something happening out in space where you'd have the element hit by a cosmic ray and that'll convert it from one element to another. Boron is part of that process. And then we get back into dying low mass stars being the major carbon and nitrogen formers. And then you get into exploding massive stars as the big oxygen, fluorine, neon, sodium, magnesium, and up. And then you start getting into silicon, maybe as a third of those atoms come from exploding white dwarfs. So a big star going supernova is different from a white dwarf accreting matter on it and then eventually going as a type 1A supernova. So it's
right. All of this has been discovered just within the last 3 years.
Right. Yeah.
I mean, we thought supernovas created all the heavy elements, and that's
right.
not necessarily true.
Right. They always had a hard time showing it. You know, that was the theory, that it did happen like that. And then when you get into the real heavy stuff, like I think gold is maybe the 79, it's actually merging neutron stars form all these orange heavy elements. And dying low mass stars where they turn into a planetary nebula and emit solar winds, I think, that populate different atoms out into the cosmos.
This is a great graph. Holy cow. I love it.
So there's a ton of information in here. If you ever have a favorite element, you can kind of use this to look at the 6 different processes that help form it. You know, the one thing that always amazed me is they said when on this one merger of 2 neutron stars, it actually formed maybe 10 or 12 Earth masses of gold all in one neutron star merger. So you can imagine having 10 Earths of all just gold. So I kind of thought that was pretty cool. Whoops, it gets even bigger. So we'll get by there. So that's the periodic table of elements for an astronomer. I've got this one topic here, Racing to Space, where Marcus House talks about a lot of startup companies, but it's a little lengthy. I'll probably skip that right now. I know we're all big fans of inflatable modules, and Sierra Nevada announced that they're planning to build one and try to put one into space. And I'm not sure.
Is this an offshoot of Bigelow, or?
You know, I think they developed it in combination with Bigelow. I think they mentioned Bigelow here, but I don't know how much.
Yeah, you haven't heard much about his company lately, except for it's still attached to the ISS for storage.
Yeah, I think this is Bigelow's kind of test module on the space station here. But what Sierra Nevada is looking for is something even a little bigger with a lot of internal structure on it. And let's see what else I got to say about it. There's, I think, a little short video here. Let's see how much they have to say here.
This is an inflatable habitat that could one day house lunar astronauts.
That's huge.
Yeah, it's a lot bigger than Bigelow's.
50 years ago. To be exact, Apollo 11 astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins completed the 239,000-mile journey on July 20th, 1969. Now, Sierra Nevada Corporation is one of the private sector companies trying to get us back. The company is developing what it calls the Large Inflatable Fabric Environment at the Johnson Space Center in Houston, Texas. Sierra Nevada hopes NASA will use the habitat in its new Artemis program, which will lead the U.S. back to the moon and eventually Mars.
Maybe part of Gateway?
Yeah, I would assume so, yes. Definitely.
The company's competing with Boeing, Northrop Grumman, Bigelow Aerospace, and NanoRacks. Each company has proposed its own habitation prototypes. NASA began testing the prototypes on the ground in March. The space agency says those tests should last several months. Sierra Nevada's CEO says there are economic reasons to return to the moon.
It's a great technology. I really hope they keep going.
Mining,
right.
To scientific and to overall space from LEO, GEO, multiple levels of the space domain. There's incredible potential for medical. There's some medical research, pharma research that you can do microgravity environment. You can do materials, you can do 3D printing. You can bring a lot of the heavy industries up to space, eventually make the Earth greener. But that all depends on affordability, which is really driven by reusability.
Sierra Nevada Corporation's prototype of its habitat is 27 feet in diameter, 3 stories high, and inflatable. And it has a micro-meteorite shield built around it to protect the structure from space debris.
The whole key is getting out there with a large enough habitat for a crew to be able to support a crew for, you know, a 30-day mission, a 60-day mission, and even we had a requirement on this for a 1,000-day mission.
The challenge, however, is how to get such a large structure into space. Currently, missions to space must use rockets to escape Earth's gravitational pull. Because the habitat is inflatable, it can be packed into a standard rocket. Once it gets to space, the company says it can be inflated fairly quickly. However, NASA decides to deploy it.
It could be used as a LEO space station as well as lunar space station and beyond toward Mars. It could, this inflatable concept can be used on the surface of the moon or the Mars, because eventually when we want to have a sustainable presence, we need all of this. So it's really a good example of our innovative approach that is very affordable because it can be launched from commercial launch vehicles.
Inside,
God, imagine the weight savings.
Yeah. There's a personal hygiene station that allows astronauts to clean themselves. Although showers are basically a spit bath, the kind you take on a camping trip, astronauts use very little water and waterless shampoo. A space toilet operates with suction and is adaptable for men or women. Urine is treated and recycled into drinking water. The habitat is equipped to capture humidity from the cabin, which can turn it into water. There's also exercise equipment. Exercise is necessary because it helps slow down the loss of bone mass in space. And it's good for cardiovascular health, as well as the morale of the crew. There's even an astro garden where astronauts can grow their own vegetables. The plants also capture excess carbon dioxide from the cabin. In the galley, most food is freeze-dried, or MREs, which are meals ready to eat. A built-in trash compactor compresses trash into bricks. Those bricks can be used for extra radiation protection. It took Sierra Nevada 9 months to build the prototype for the habitat. And it's still—
No, that's no time at all.
The shell can withstand micrometeorite debris. It's been nearly half a century since humans have walked on the moon. NASA wants to get back there soon, though. And in addition to an orbiting habitat, either from Sierra Nevada or another company, the agency also wants to establish a lunar base on the surface. NASA says it plans to return to the moon in 2024 to be exact. Low Earth orbit has almost been commercialized through private companies like Elon Musk's Spacex. That potentially leaves NASA free to focus on the moon. And then Mars.
Good video.
So that's, you know, kind of an interesting development there. We'll see what comes out of that. I had a couple other topics here about cooperating with China. If you remember Chris Hadfield, who sang that rendition of David Bowie's Space Odyssey, he came out with a essay saying that we should cooperate, you know, that he knows the dangers of technology transfer to China, but there's still a better, I think, things to be gained by cooperating. So we'll see. I'll be kind of curious how the new administration looks upon China. Like Dean said, they're doing a lot. You know, they've got the rover on the far side of the moon. They might land their rover on Mars. By the end of the month, they should be launching their first module for their space station. And it's not a lightweight thing. It's going to be a 22 metric ton initial module. So it's going to be big stuff.
So maybe next time we can talk about the possibility of Russia pulling out of the ISS program by 2025. And what that means for the ISS, and other things. So that would be a great topic to touch on next time.
Right.
Yep.
And then, you know, SpaceX, we've got the Inspiration 4 mission coming up, you know, so they're not only launching people to the space station, but they've had the billionaire contract them to do a little completely private mission with 4 people. And instead of having a docking adapter on the end of the thing, they're going to have this like a complete bubble that the 4 people will be able to float up there and have a full, almost unobstructed view out of the capsule. So that's kind of an amazing development.
Yeah, that's unreal. It sounds so neat.
Yeah, that would be cool.
Very cool.
So that Inspiration 4 mission, it'll actually go higher than the space station. It's going to orbit at 335 miles high, whereas the space station is usually around 250. And they might be up there for about a week. Again, they're not docking to anything, and they're all pretty much just civilians. You know, some of them have been pilots as a hobby, but not, you know, not military type people.
Yeah, very cool.
So again, that's supposed to lift off no earlier than September 15th of this year.
Wow.
So that's coming up. We'll count them as another 4 going into space.
Yeah.
And then, you know, we were talking about Starship explosions. Remember SN8, SN9, SN10 did it. And then SN11 actually exploded high above Boca Chica and rained down stainless steel all over the place.
Yeah, that's why it was really foggy that day, right?
Yeah, I'm not exactly sure why he launched it in the fog. All the people with their cameras saying, why is he doing this, you know?
Yeah, probably because he can.
Yeah. But definitely, you know, it seems like SN8 almost had the best chance of landing, and it's kind of been going badly the other way. So I'm hoping SN15 turns it around. And then I caught this thing here where astronauts were down at Boca Chica, and I was saying, wow, that's kind of weird. I know he's got something in the human landing system, you know, but, you know, NASA astronauts visiting. So I think that was a premonition of NASA actually going with
yeah.
it. So
yeah. Good point. Good point.
Yeah. And I think that's it. Yes. So that kind of closes it down. Anything you want to say before we shut the meeting down?
Well, the nice thing is that it's nice to see Fermilab and some physics from Illinois back in the news. And the successes that Elon Musk has had with the Dragon, I mean, has been amazing. Not to mention that we can talk next time that the type of financial pressure it's putting on Russia now, but they have these huge dreams also, you know, new space station going with China and all this. That'd be great topics for next time. But yeah, this technology demo that we've decided to try with Ingenuity has been absolutely remarkable. And it just opens up new avenues of exploration for planets in the solar system. So we'll have to keep an eye on all of that.
Interesting stuff.
Yep.
Yeah, you gotta, you know, I think I've editorialized a little bit with the group about Russia. Sometimes it's like dealing with a 5-year-old and, you know, them kind of thumping their chest and saying they're going to walk away from the International Space Station in 2024. You know, I just know the module they're sending up is delayed for like 8 years. And, you know, they talk big, but sometimes they have a hard time, you know, they're steady and reliable in some manners. And then some other manners, they're very tough to actually execute and do what they say.
I think they're kind of holding that module hostage now, because the latest I heard is that that's going to be part of their new space station in 2025. So it may not even become, because they're saying right now that their part of the station, the Zvezda and Zarya and Poisk modules, are all, getting up there in age. And as we all know, we have a few leaks in the Zvezda module that they're still trying to take care of and stuff. But the latest I heard is that Dmitry Rogozin, who is the MASSCosmos person in charge, is made a statement is that we'll probably use that segment for our space station. Well, they're missing, a lot of money from the U.S. because SpaceX and Crew Dragon has been so successful. So I don't know if that's possible. And they're talking about a new space station. Russia's talking about going with China with something on the moon. I don't know where all these rubles are coming from. Yes. So we'll have to dive a little deeper, and hopefully by the next mass meeting, we'll have some information on that. And interesting stuff coming up.
Yeah. So, okay, with that, I'll say thank you everyone for participating and joining us. And with that, I'll say ad astra to everyone.
Thanks, everybody.